All right. Hey, everyone. Hope we're all doing good today. Druha, you got first. Congratulations. And I got a ton of replies from last time I was posted on Reddit. So let's see what's been happening. I hope people aren't yelling at me. Oh, yeah. So this person, the sound did play. Did you not hear it? I'm pretty sure I have it turned on. Let me go back to that scene. Yeah, no, the sound played when you redeemed it. I was on the starting soon screen, but it still played. I guess it should have. I mean, I heard it through my end. I don't know. It's only can I play it? Because you wouldn't be able to now. No, I can't even play it myself. It should have. I have the audio source on that scene, so it should have played. Yeah, I can't even play it myself to be honest. Actually, I could go into Twitch and play it, but it's too much trouble. Oh, I wish they said they posted it on multiple things. Like, all right, fine. I'm not dealing with that then. Oh yeah, they're just asking which lines are being referred to with one and two, and I told them it's referring to the angles, not the lines. These these replies are a little bit weird. Let me see. Wait, what about the N2? I have no idea what this question means. I don't know that this is that necessary to say, but it's true. But for this person, this is a good question that they're asking. And basically their point is the problem states the measure of angle 1 equals the measure of angle 2, but they use the m here to say the measure of the angle, but m is also used over here to signify a line, and that's kind of sloppy. So let's reply to this person. Hey, Jed. It's bad form. I mean, it's maybe not bad form, but it's confusing. How loud do you need your car to be? Okay, sorry, I don't know if I might pick that up, but people go roaring by in their cars all the time, and it's kind of annoying. and the line M are completely unrelated. Well, I mean, I shouldn't say they're completely unrelated, except that the line M happens to form part of the angle 1. Okay. Okay, I don't know why people are replying with the same exact things, but the person got their answer. So I don't think I need to say anything else. Let's see. Oh yeah, they're trying to solve this for R. And they're just said thanks. Okay. Oops. Come on. This one, so they, oh yeah, they asked for someone to check their work here for this page, especially for number 8. And they just said thanks. Okay. That one I already looked at. That one I already looked at. I was asking how to graph a circle in a graphing calculator. I explained how. And they're just saying thanks. Okay. And then all these are the same thread. Okay. 10th grade pre-calc. Formula that satisfies the. Ooh. We have to find a formula or a function that satisfies this. Well, this isn't a function. But how would you get this? We could do 4, like, if you wanted to call it a, well, yeah, because you could do a piecewise and call, if you're only looking at the upper half, you could call it a piecewise and say this is one function here. This is another function here, like split up with the positive and negative parts. But having it reflected down here is just weird. Why? Like, this isn't a function. This isn't the type of thing um, students normally need to deal with. You could be lazy and put like a plus and minus. Like, you could only get the graphs for the upper half and then just stick a plus and minus in front of it to get that reflection. This is odd. Like, I'm trying to think how, like, the equation for a circle, could it be like absolute value of y equals absolute value of x? You do just the first quadrant? Uh, yeah, probably, but I do wonder what this looks like. Makes an x. Okay. Well, so your normal base y equals x. It never goes negative. You can make the y also an absolute value, then you can go negative. I feel like we take absolute value of y equal to absolute value of x as our base, and we need to transform this to get something remotely similar to this. If I stick a negative sign in front, this has no solutions, I think. Yeah, there's no solutions here. So what if we did that, the negative inside? I want to figure out how to, well, we need to shift it up by 3, so we could get that shift in. Wolfram Alpha is kind of choking on this. Dan! Thank you. Hang out because you're working. No worries. Thanks so much for coming by. Let's try putting a nice sign in front of the Y too. Let's see what happens here. I might have just double reflected and achieved nothing. Okay, yeah, I double reflected and achieved nothing. Okay. We're almost there for at least getting we have the shift the shifting right. We've shifted to the right by 1, and we've shifted up by 3. But we need to get this facing down. I don't know how we achieve that. Could I have a solution if we do 3 minus that? Oh, there we go. Okay, okay, okay. This is such a weird question to ask of a student. What 10th grade pre-calc and they have to get a graph like this? Um, Thanks, Friskin. I'm good. How about you? So this is basically what we want, but we need to basically chop off the negative part and instead have a reflection. I don't know how exactly we'd achieve that. And also, I kind of wonder, I want to put up a new type of wolfram. What if we did y plus 3 absolute value equals, like, what if I put this in a slightly different way that might also achieve the shifting and maybe get this reflection? Like, what does this graph look like? Oh, implicit plot? I guess not. That's also implicit plot. Hey, no pro Bob. Yeah, I mean, what you're saying is true, but if you're gonna do a piecewise function like that, you may as well just like not even deal with this whole absolute value of y equals absolute value of x thing. Like you can this will I feel like you may as well just define separate absolute value functions for the top and bottom. I'm interested in trying to figure out this way that we can do all of this in one go if we can. I doubt it, but yeah, doing it as piecewise would be like easier, I guess. Power squaring each side? We can try that. Would we do this like an absolute value squared? Okay. Wonder what that's gonna look like. I don't know what that graph is like. Maybe. Thanks for the follow. Oh, that's, that's an interesting graph. Yeah, is the absolute value of the y redundant? I wonder. Change x to absolute value of x? Can you give hints? Wait, so are we gonna have absolute value inside an absolute value? Luigi, let me. Actually, well, yeah, sure. We're not trying to do this blind. Oh, it's like a Mario and a Wario symbol. But yeah, no. If you have an idea, please say it. This is the graph that we're trying to reproduce. Like we could of course do a piecewise function, but it'd be cool if we get this all in one thing. Oh wait, no Luigi. Yeah, you're right. No Luigi symbol. So wait, this is almost right. Or is this exactly right? Like, so it hit at 4 in the, it's just the, oh, wait, Jed, yeah, you just got it here. Because it should hit the x-axis at 4. It's just the, oh, you need to pay them. No, I'm pretty sure this is already right. We just need to, if we were able to zoom it out a bit. I mean, we can try removing the square and see what it does. I forget how you zoom out in Wolfram. Oh, okay, that time we graphed it properly. Okay, I guess, yeah, you are able to remove the squared. Interesting. Luigi, was this what your idea would be too? Or did you have a separate way to try and get this? I don't know if Desmos can do this. I think that Desmos forces you to do y equals, and you can't do absolute value of y. Absolute value for and hope. Yeah, basically. It does? Oh, okay. Must be misremembering. Yeah, I think No Pro Bob is right about not squared is better. Because here it does go off to infinity plus and or like before and after x equal 4 and negative 4. Yeah, no, this is super weird to give to anyone, but especially a 10th grader in pre-calc. So if we took the squared away here, it becomes unhappy with me. Oops. Oh, it doesn't like this without the squares. Interesting. What if I just manually retype that? I wonder if it was like a weird thing with the copy paste. Was it -1? What is that box? Wait, stop it. Okay, wait. I don't think Desmos likes this without the squares. Okay, that got it. Thank you, Jed. So you start with absolute value of x, shift down 1, take absolute value of the result, and shift down whatever's needed in the problem. Okay, I think I accidentally followed that train of thought without like knowing where it would lead. Okay, what a bizarre problem, but I guess we figured it out. Yeah, The squaring is a good try though. Yeah, no, because I was trying to develop a square too because I was thinking of like circles. Ed Sheeran stunt double tag. Thank you. Yeah. Weird problem. Dude, they didn't post their attempt. This is such a weird problem that I kind of just want to post the answer. Like, I don't know how it's possible to like I feel bad that they have to solve this. I don't know how to give a hint on it anyway. Brute force it and define piecewise. I mean, I don't even want to call it function, but I'll call it a function. Yeah, that's a hint, Luigi, but I just can't give them the answer. 'Cause at some point, I feel bad for the student. They have to do a problem like this. Like, I don't know how it helps them to be able to construct this. I I I I know it's not a function, so I was gonna make something like disclaimer. Piecewise function, although this isn't a function. This isn't technically a function. Is piecewise equation a thing though that also feels wrong? Actually, even then, like you don't really define a piece. I've never seen a piecewise function or equation defined where you define it for like a range of y values, which is what you'd have to do here. Piecewise relation. You know what? Maybe I don't even want to mention this because like I've never, I haven't encountered like a piecewise equation, relation, function, whatever that defines things for ranges of y values. So you could, I guess, still like do a piecewise function for the or function. I'm just gonna say the word function because that's what I'm used to. But you could in theory define one for the positive x's and the negative x's and just still get the reflection somehow. But and do I even want to go here? It's kind of just confusing. They do say equation. Eh. Honestly, I I don't really care that much about the difference, especially for this person's like purposes. But it's probably better to get it all in one equation anyway. I'll start saying equation here. So let's start by looking at the normal case of absolute value with y equals absolute value of x. So I kind of want to follow Luigi's workflow for getting to the result here because I think that's a good approach. Like focus on the vertical shift first, and then just get that like reflection on the top and bottom. So I think that's a good way to kind of like get this working. Equals absolute value of x is a v that opens upward. Let's first focus on making this, I mean, open downward. Well, let's first focus on making it open. Let's first focus on shifting this function up and making it face downward. Then we'll reflect it from below at the same time. Because it's kind of happens at simultaneously are flipping and reflection. You can't really get away from that, I don't think. We want to shift up. Let's add 3 to the right side. Y equals absolute value of x plus 3. Now we want it to face down. So let's negate the thing involving x. So y equals 3 minus absolute value of x. And actually, what is that graph? I think that'll just be the same. It'll just be a v going downwards, right? Shift it up by 3. Okay, good. Shift it up and opening. Actually, it's not really happening. The reflection isn't happening at the same time. We can do this separately. So let's work on the reflection next. We want the y values to be mirrored from above and below. So we also need to take the absolute value of y. Absolute value of y equals 3 minus absolute value of x. Okay? We're working our way through the transformations. And this should give us basically a box, I think. Yep. Finally, actually, let me go to a new paragraph. Finally, we need to incorporate the horizontal shift while preserving the reflection across the y-axis. It's a weird noise. I mean, sorry, this is distracting me. Well, let me see what is happening. Oh, it's coming from outside. Okay. It sounded like it was coming from my heater that's turned off. I was like, that seems kind of concerning, but I think it's just someone doing yard work far away. Okay. To accomplish this, we'll need to subtract 1 from x, or to shift right. One from x. And if we didn't have the extra absolute value, we get something that I saw before, right? Okay. Yeah, absolute value of y equals 3 minus absolute value of x minus 1 doesn't preserve the reflection across the y-axis. So we need what's italics? Single. Okay, yeah. Another absolute value around just the x. Yeah, for this one, it's such a weird problem that I really don't mind explaining the entire thing and giving away the answer, because why the heck would you ever need this? So I think let's post this. High school geometry, is this right? Posted a minute ago. Oh shoot, my mic. Dang it. Sweatshirt is a little floppy. Hopefully my mic wasn't sounding too bad. Zach! Thank you so much. Welcome in, everyone. If anyone was here on my end, check out Zach. He also streams math. How's the stream? Hope it went well. Right now, oh god, that's way too much of a zoom. We had some very interesting problems. Oh, nice. We just we're looking at a pretty interesting absolute value one. Basically, they had to find an equation to make this graph, and we're able to work out the solution eventually is this annoying looking thing: absolute value of y equals absolute value of x, and like, yeah. Yeah. So we needed 3 different absolute values, but we got there eventually. Prav, I'm not even going to try to pronounce that last part. Thanks for the follow. Yeah, so that was a pretty fun one to try and work out. I'm just looking at this one. It looks like they're applying the distance formula in some way. Distance between 1 and 2 and x and 5 is 5 units. You have to find x. Okay. X minus 1 squared, 5 minus 2 squared equals 5. That's good. Whoa, did they say x minus 1 squared is x plus 1? That's not right. I think this person distributed the squared, maybe? They actually initially wrote x squared plus 1, but they erased that squared from the x, I think. It's very faint. So they need to FOIL this correctly. This part over here is fine. There's a weird squiggle thing over there, but I don't think that's a squared. You get root x plus 10, square each side. They do get a nice clean number, which is kind of funny. Let's figure out what the answer is supposed to be. Someone's probably going to beat me to it in the process, though. Oh, wow. 2 people already. Okay, they're both right. Here's the squish out number 1 earlier. Oh. That's a little sketchy then. Sometimes they're just trying to get people to do their homework for them. I guess we'll just leave it. I mean, I kind of want to see what the answer is, just out of curiosity. So let's just do it for fun, but that's true. Actually, no, that's right. They posted their attempts. That's fine. But I'm interested because the algebra is going to be a little bit weird. for doing that one. I want to see how it's going to work out. So you might get into a situation where you... Wait. That's not a square root. Where you need to like factor something and throw out one of the answers, which often throws students off. So that, I skipped ahead a little bit, but that was the question. That is x squared minus 2x plus 1 plus 9 plus 10. That doesn't factor, I don't think. So we square each side at this point. And then we subtract 25. Does that factor? Oh yeah, 5 and 3. And you can't have a, well, you can have a negative x here. So oh, that's true, no problem. Series convergence? For the normal ones that you encounter in calculus class, yeah. So I think, how do you know which one is, I guess they're both. Because you can't, yeah, I guess they're just both solutions because the next coordinate is allowed to be negative. Shouldn't this be a circle? Oh, no, we're fixing the y coordinate at 5. So yeah, there's just two solutions. That's a little weird. Yeah. Okay. It's basically a circle, but you only take like one like line through that circle rather than all the solutions. I don't know if they posted the question right or if that's just like the question they were given. It's not their fault, but either way, I don't understand it and I can't help with it. A residual analysis. Okay, so for this, the residual analysis part, I haven't heard of, but, well, okay, let me look up what residual analysis is. The endpoints of a diameter to any...
Christ, you cooked the shit out of it!
Connecting the endpoints of the diameter to any other point in the circle forms a right angle. That's interesting. I feel like we've encountered that theorem before. I forget why that works, because that feels weird that it would be a right angle. Oh yeah, if you I remember now. I was looking at the wrong thing. Or I was visualizing the wrong thing. Okay, the residual analysis part I don't really understand, but I know how to take like, or oh, did the thing not play for on stream? Because I heard that through my end. The thing that Jura just did. It should be working. Like, I haven't messed with it at all. Like, do you guys here want to do this?
The shit out of it!
Because on my end, it looks like it's going through on stream. If it's not, I don't know what to do about that. You hear it? Okay. Oh, in Twitch chat? Triggered again. Oh, it's still on cooldown. I'll do a different one. There we go. I mean, you're getting me there, Druha, because half the stuff you say is just being an asshole, but you're not there yet. Uh, I don't know, I'm kind of gonna I kind of want to say that I don't understand the residual analysis part of what they're saying, but whenever it comes to interval, if your like test point is inside of your interval, you say that it's good. If it's outside the interval, you say it's bad. It's basically the same as a p-test. So you draw a circle of radius r, perfectly centered at the origin. You find a random point in the circle and prove the slopes of the segments going. Oh, okay, that does make it a lot easier, Luigi. Yeah, I'm not sure how you'd prove that in a it's like a void like you normally do geometry in. And then just got done helping a student in a medical math with dosage calculations. I'd be nervous about that. The calculations with that, I never actually learned them, so they're super weird with like dilution and like things like that. I feel especially nervous about like medical math too, for that reason. Yeah, you're gonna need a bucket for 3 liters. Not really a bucket, but I mean, I guess like a small bucket. Um, Not sure about the residual analysis part, but normally when you use a confidence interval to test a value, you'd but a confidence intervals is basically the same as a p-test, just for a different purpose. You need to say, was that for something in liters or gallons? I'm trying to remember this about it's like a confidence interval is really just a p-test, but you say like what is the like, you know, lowest value you'd still accept to reject the null. If it's inside the interval. Oh wait, I should Google this. I think maybe if it's outside the interval, you null values embraced, it is certainly not rejected. There we go. If the interval includes whatever your null is, you'd fail to reject it. Or if the interval is completely outside the null, you would reject it. Is there a math streamer after this stream? I don't remember Dan's schedule exactly, but he's the one who normally would be going in a few hours, I think. And if you're still around, please advertise yourself and your schedule, Dan. But I don't remember what days Pen Center streams either, honestly. That's kind of bad. I should actually get a command for like people's normal schedules or something like that. Ooh, we got some integration here. Which one are they asking about? Number 7? I don't want to look at that person's profile picture. Oh my god. Toad with human legs? That that makes me uncomfortable. Never. For number 7, let's make it bigger. For double check? No, that's not a save. All right. 1 second while my dial-up loads this picture. Rowdy, it's meth time? You know it, man. Oh, it's Thursday, so it's your slow day, right? Rowdy? Hey, you're chilling? Nice, nice. How goes it? Pretty good. I haven't found a ton of math questions today, but that's how it goes sometimes. You know, I mean, it's been so long since we've run. Like, I don't know how the servers are looking these days, but if you wanted to run some DayZ in like maybe half an hour or so, uh, some good old times. Actually, what even like Azure as a good amount of like population, but it's up to you. I mean, honestly, I would play anything. You're down for whatever. Ooh, all right. It's been a while since we played. Yeah, if you don't mind, like I'm not quite up to 2 hours yet, but like another like half hour or so. You the answer is 7? Yeah. Rowdy always knows. All right, so this person asked me about question 7. You would have guessed shade. Yeah. Wait, where the heck is the math Discord again? Okay, yeah, it is 7. Excuse me. So we need to do a substitution here. They did u equals 2x minus 1. Oh, this might be a fun integral here. I don't know exactly what integration or what sub we want. The integral of x squared minus 1 over root 2x minus 1 dx. Okay. And so the problem is like we can't really relate these to each other that cleanly. Like if you do u equals 2x minus 1, you can't really get rid of the numerator in the way that I can see. You could maybe split it up into 2 separate terms. and have just an x squared over root 2x minus 1. I don't know how you integrate that, though. I might want to Wolfram this. Because actually, they might have made U sub actually work in a way that I haven't seen before. But let me make this Wolfram Alpha's problem just for a second. Wait, I thought I deleted that. Let's get a fraction x squared minus 1 over 2x minus 1 dx. What U sub does Wolfram use? It does u equals root that. Really? Huh. Okay, let's try that. They really don't explain that too much, but there must be some relation between root 2x minus 1 and x squared minus 1. I'm not sure exactly what that is, but let's see if we can reverse engineer it. One over 2 root 2x minus. Wait, no, it should be 2 over that, right? No. Oh, I see. The 2 will cancel with the 1/2. Okay, so it is just 1 over root 2x minus 1. And ironically, we never actually use this first line on that part because it's going to cancel when we do that. No, wait, we do. Because it's u equals that. No, we don't. Okay. So if we... I'm not going to sub this. I'm going to keep it as is because when we do this, we're going to get a cancellation. Let me actually show this. 2x minus 1 times root 2x minus 1 du. Now we get a cancellation. And when you figure out this x squared minus 1 business, you're rendering off this PC whenever you're ready. Oh yeah, sure. Sounds good. So we need to somehow get an x squared in here with this in order to make this sub work. So let's square each side of that. Do u squared equals 2x minus 1. Now, do we square it again? Doesn't seem right. Water guns only. Oh, I see. We add 1 to each side, divide by 2. Equals x. And then we square each side. And we couldn't have gotten it as x squared minus 1 because that would mess up when we square each side. Interesting. Okay. 1/4, oops, squared. U squared plus 1 squared minus 1 du. And this we know how to integrate. It'll be a little bit painful, but we know how to do it. 1/4 u to the 4th plus 2u squared plus 1 minus 1 du. Let's distribute the 1/4. U to the 4th plus 1/2 u squared plus 1/4 minus 1 is minus 3/4 du. A nice integration technique. Yeah, I did not think it would be like this. I'm glad I looked it up in Wolfram because I wouldn't have got this on my own. So when we can now integrate this term by term. So we get 1 over 20u to the fifth plus 1 over 6u cubed minus 3 over 4u plus c, I guess. I'll say the plus c for the very end. And now we know that u is equal to root 2x minus 1, so we can do an unsub. 2x minus 1 to the 5 over 2 plus 1 over 6 2x minus 1 to the 3 over 2 minus 3 over 4 root 2x minus 1 plus c. Let's see what this person did here. Wait, Wolfram Alpha's answer looks different. Oh, or I think they simplified it further. So you can factor out the root 2x minus 1. Really? Shouldn't there be a to the 5 term? Did I do this wrong? So I don't think what I got. You have to derivate the substitution or something? I did up there. Unless you're meaning a different part. D over dx equals u prime. Oh, okay. One quarter u squared plus 1 squared minus 1 du. I did do that right. How does Wolfram Alpha not have a to the 5th term? I don't know how you avoid that. Let me give it the integral from maybe that step. Or oh, you can't see what step that is, but I'm about to write it out here anyway. I'm going to do it with x's instead of u's, just to make it more confusing, I guess. It's 1 squared minus 1 dx. Okay, that is an x to the 5th term there. That matches with what I got. Wait, 3x? Oh yeah, no, I got that. Okay. So if I instead give it maybe my very last part, is there some kind of cancellation that I'm not seeing? 2x minus 1 to the 5 over 2 plus 1 over 6, 2x minus 1 to the 3 over 2 minus 3 over 4, 2x minus 1 to the 1 half. See what Wolfram Alpha does with this? It should look for simplifications. It does simplify to hell. So I think I have the right answer. I really don't get how you go from this, oops, down to this or that. Because surely you have an x to the fifth term. Like, okay. Let's try it. Let's go over here. Just see what happens after we factor that out. Maybe there's some crazy thing that I'm not seeing here. Actually, let me, oh, no, I'll rewrite the initial line. Minus 3 over 4 root 2x minus 1. And I'm going to ignore the plus c. Who cares about the plus c? So the first step that you seem to want to do here is factor out the root 2x minus 1. You could also factor out a 1/2, I guess. And inside here, you get 1/10 2x minus 1 to the fifth, which is what's confusing me. Plus 1/6 2x minus 1 to the 3. Unless I'm misunderstanding something horribly, but I don't think I am. Minus 3/4. And so how do we have 2x to the fifth, but only end up with a squared? That's where I'm confused on this. No? Am I factoring this out wrong? Zone Ranger, please correct me. Release me from my poor algebra. Oh, wait, you subtract 1/2 when you do this, right? Is that it? You're gonna figure it out yourself? Oh, okay. So sorry about that, Spectre. I didn't even see that. X to the a times x. X to the a plus b. So we would subtract 1/2. That's it. Okay. Thank you, Zone Ranger. So yeah, we don't divide a half, we subtract a half. So when you, let me just, okay, I'm gonna do this separately in another color. Blue. 2x minus 1 to the 5 over 2 is equal to, basically what we're doing is root 2x minus 1 times 2x minus 1 squared. I should have done a square. I should have done a 1/2. Because when you multiply these back together, you add the exponents, not multiply. Thank you, Zone Ranger. Oh, and thank you for doing that, Spetri. Yeah, that's definitely a save. Okay. Well, I understand this now. I just don't remember basic exponent rules, I guess. So when you factor out the root, you get squared here. You get just 1 there, and you get 0 there. Okay, that makes sense. I don't feel the urge to bring it all the way to the end, but you could multiply this out and multiply that out and combine like terms. We don't need to know that for the sake of helping out the person who was asking the question, though. Thank you for that, Zone Ranger. Don't do it, Spetri. Oh, they... Okay, well, that's still a fun problem. It got resolved, though.